This video is going to cover the topic of factoring expressions. Be sure the date and topic are at the top of your page. The essential question says, how do we factor an algebraic expression? And the good news is you already know how to do this. You practiced most of this in 6th grade, and we mostly used the cake method. Let's say we want to find the greatest common factor of 12 and 20. I would put both of these in my cake, which looks something like this, right? It can be called lots of different things. And then I think, well, what can I divide both of these numbers by? Well, I can divide them both by 2. 12 divided by 2 is 6, and 20 divided by 2 is 10. But then 6 and 10 can also be both divided by 2, which leaves me with 3 and 5. And that's as far as we can go, right? So the greatest common factor is found on the outside here of our cake. So the greatest common factor is 2 times 2, which is 4. We do the same thing when we are trying to factor an expression. If we have 30x plus 75, I'm going to put both terms into my cake, and I'm actually just going to leave this addition sign there so I don't forget about it. And I'm going to try to think about what I could factor out. So I know that these can both be divided by 5, and 30x divided by 5, well, 30 divided by 5 is 6, so it's 6x. And we would have 75 divided by 5 is 15. But that's not quite as far as I can go. They can also both be divided by 3. 6 divided by 3 is 2, so that's 2 x's. And 15 divided by 3 is 5. And that's as far as I can go. The GCF can be found by multiplying these two, right? So the GCF is 5 times 3. Maybe I should change that to 5 times 3, which is 15. And now I have everything I need to rewrite this expression. My greatest common factor is 15. And inside the parentheses, I'm left with 2 x's plus 5. It's just that bottom row of my cake method that moves right over here. The next example has 3 terms, right? And that's okay, we can still do that. So I have 12c plus 36y plus 42, and I'm just gonna go ahead and make my cake method right on the original question here. I know they could all be divided by 3. Maybe I needed my multiplication chart to know that, but I've got that figured out. If I have 12 divided by 3, that's 4. So I still have my 4 c's. Plus 36 divided by 3 is 12, which means I have my 12 y's. And 42 divided by 3 is 14. And that's just a constant. There's no variable there. Looking at this again, I notice they can both be divided by 2, or all 3 can be divided by 2. That leaves me with 2 c's. 12 divided by 2 is 6 y's. 14 divided by 2 is 7. And at that point, I think that's as far as I can go. So here we have 3 times 2. That's my greatest common factor of 6. So I'm going to take 6 and put it outside my parentheses and rewrite everything that is still left. That is an equivalent expression. This one's a pretty quick one, but maybe you notice right away that what's different about this is that there is a subtraction symbol. It doesn't change anything. So I'm still going to go ahead and say, 3 and 33 can both be divided by 3. 3 divided by 3 is 1, so that's just 1h. 33 divided by 3 is 11, but that symbol was a subtraction, right? So I'm going to go ahead and keep that there. That's as far as this can go. My greatest common factor is simply 3, so I'm going to do 3h minus 11. Notice I didn't use that 1. I don't really need to have that in there, right? The h by itself is just 1. And again with 2 terms, I have negative 8w minus 12. This time both of our terms are negative. And I'm going to still keep that in my cake, right? So I'm going to go ahead and do this. I know 8 and 12 can both be divided by 2, but since they're both negative, I'm going to divide them both by negative 2. Negative 8 divided by negative 2 is 4. Negative 12 divided by negative 2 is a positive 6. Those can be divided again by 4. 4 divided by positive 2 is 2. 6 divided by positive 2 is 3. When I look to see what my greatest common factor is, negative 2 times a positive 2 is a negative 4. So that means my greatest common factor is negative 4 with 2w plus 3 remaining inside the parentheses. So sometimes you might be able to divide both numbers by a negative number, and that's okay, right? We've seen negative numbers outside our parentheses before when we've done distribution. This is one final example that shows something a little different. Sometimes we can factor part of the expression, but not all of it. In this example, I notice right away that 4 and 10 both have a common factor, but 3 does not, right? So I'm just going to factor the part that I can. I'm just going to go ahead and factor this portion here. So 4r and 10 can both be divided by 2, leaving us with 2r's and 5. That's as far as that's going to go, right? So my greatest common factor is right here. So I have 2 times 2r plus 5. And then I'm just going to bring down the part that wasn't involved. And it looks something like that. We've seen things like this before where some are in parentheses and other pieces are not, and that's okay. And if I needed to, I can rearrange things to make it easier, but this worked out perfectly. So just be mindful that that can happen sometimes. To end, we're just going to write a couple general rules or processes to have handy. So the first step is to find the GCF of the values in the expression. And feel free to use the cake method. Once you have the GCF, you're going to write it outside a pair of parentheses. After which you would take that last line of your cake and go ahead and put it inside the parentheses. And lastly, bring down or carry down any of the terms that weren't part of your cake, if any, and keep those outside the parentheses. So remember, this video was meant to give you a little bit of a insight into how we factor algebraic expressions. We've seen a couple examples, and we'll of course be practicing more in class.